All right, good morning. Let's switch over to problem one of two. That's called t-test, hypothesis test for the mean. And I'm going to do a couple of things here. If we think about where we've been so far with hypothesis testing in this mastery section, we've exclusively looked at one type of problem, and that is hypothesis test for the mean, where sigma, the population standard deviation, is known. Okay, and we've looked at the traditional method and we've looked at the p-value method, and I think you've seen how the number of steps and the time it takes to do the problem with the traditional method definitely is significantly reduced with the p-value method. And maybe you're even warming up to the p-value method, since that p-value is a probability. It's a probability of getting the result that you got in your sampling, or an even more extreme result. And maybe it's a more direct way to do that. So let's just add a little bit onto this. Let's look to see what happens when we have a situation where we're doing a hypothesis test for the mean, but sigma is unknown. And we're going to run through it very quickly. You're going to see that it's exactly the same situation. However, you don't know sigma. What you do is you use S, the standard deviation from your sample, as a substitute, and you trade out the student t, sorry, the normal distribution for the student t distribution. So we can do that in a heartbeat, but I'm going to show you something else yet that will make your life better. So let's quickly run through this and the second problem in the next video. So problem one says science fiction novels average 290 pages in length. The average length of 10 randomly chosen novels written by I.M. Wordy was 365 pages in length with a standard deviation of 50. Sorry, so let's read that again. Oh, all of a sudden I get a standard deviation. Yeah, it's the standard deviation of those 10 novels. It's the standard deviation of your sample. It is not the population standard deviation. And at sigma equals at 0.05, are Wordy's novels significantly longer than the average science fiction novel? So I've written down the problem here. Let's just walk through it. What's the null hypothesis? Back to the status quo. Science fiction novels average 290 pages in length. Mu is equal to 290. And what we're testing is, are this one particular author's novels longer? So the alternative hypothesis is that his novels are longer. The mean number of pages is greater than 290. Significance level is 0.05. If we look at the alternate hypothesis, mu is greater than 290, clearly a right-tailed test. And let me just draw in the area associated in the right tail with 0.05. So you can see alpha pointing to this area, which is to the right of, there are two lines there. The one on the left is the one for which that's the line in the sand associated with alpha. And the area in the tail there is alpha. So all we have to do now is calculate the p-value, see if it falls to the right of the line in the sand, right? It's an even smaller area, or if it's a larger area, and then we'll decide what to do. Well, great. How the heck do we do that? Pull out the calculator, okay? Now this just turns this problem into data entry. It's as simple as that. If you can turn the calculator on, you got a good chance of being able to do this. So let's look at that box down in the lower left. It says go to stat. Once you're at stat, scroll over to test. Once you're at test, the second item is called t-test. Let's go down there. Okay. And when you do, it's got an input page, and that's what that little blue box in the left-hand corner is. It says, first of all, what's the input? You've seen that before, data or stats. So we don't have data, we've got stats, so let's select that. Then it says, what is mu0? What's the null hypothesis? 290 pages. Then it says, what is x bar? The mean of the sample that you have selected, 365. Tell me about the standard deviation, S of x, 50. how many, how big is the sample. And I just want to make sure, yeah, the average length of 10 randomly chosen novels, it's 10. Now, that next to the last line basically is asking, is this two tail, left tail, right tail? So it's basically asking you, what is the alternative hypothesis? Is it that mu does not equal 290? No, that'd be two tail. Is it that mu is less than 290? That'd be left tail. Now you have to select the rightmost selection there, which you have to read mu is greater than mu 0 or mu is greater than 290. Okay, having done that, you get the choice of calculate or draw. I don't think draw is worth anything. Let's hit calculate. And when you do that, I'm going to do that right now, you get all sorts of results. And I didn't put them all down because so what you get is mu is greater than 290. It actually gives you t, the critical t value associated with, that's actually, I'm sorry, that's the test statistic that you would compare to the critical value if we were doing the traditional test, but it gives you p. And in this case, I get p is equal to 5.2693 times 10 to the minus 4. On the slide it shows up as 5.3 e to the minus 4. So that's a very small number, that's 0.0005, right? And so it's clearly less than sigma. Back to the picture, P is a small, small area. It is an even more improbable result than what we have decided is improbable, right? We've said anything with a probability of sigma or less is unusual. We've got the value P much less than the probability associated with alpha, if I said that right. And so you reject H0, all right? So there's absolutely nothing wrong going forward with using the calculator. I absolutely want you to understand what you're doing. I think we're starting to do enough of these problems that maybe you do, and the calculator will not injure you too much by using it. Okay, off and running. Let's go to the second problem. All right, problem 2. Let's use our newfound skills here to dispatch this problem very quickly. It says Reginald Brown, an inspector from the Department of Weights and Measures, weighed 15 18-ounce cereal boxes of cornflakes. He found their mean weight to be 17.8 ounces with a standard deviation of 0.4 at alpha is equal to 0.01. Are the cereal boxes lighter than they should be? Okay, so if you got that through my reading, good. If you did not, you might have to look back. The null hypothesis, these are supposed to be 18-ounce cereal boxes. It's kind of a nominal value stamped on the box. So mu, we're still testing the mean, mu is equal to 18, but there's a concern that these boxes actually contain less than 18 ounces, and in fact a sample found 17.8. So the alternative hypothesis is that mu is less than 18 ounces, all right? The significance level this time is 1%. If we look up at the alternative hypothesis, it's got a less than sign. That will make this a left tail test. Let's look over at the diagram, and there you see alpha over the alpha area, the probability associated with the significance level over in the left tail. And now all we have to do is compute the p-value. Pick up your calculator, go stat, tests, t-test, and work your way down. The input is stats. The null hypothesis the value for for mu is 18. The mean of the sample that we have selected is 17.8. The standard deviation of the sample that we've selected, remember this is a hypothesis test where sigma is unknown, is 0.4. Reginald Brown weighed 15 boxes, n is equal to 15. This is a left tail test, so we're not looking at mu is not equal. We're not looking at mu is greater than, we're looking at mu is less than 18. Just look up at at the alternate hypothesis over, and now move down to calculate. And when you do, you find that the p-value is 0.03. So let's plot that. And note it kind of falls in this non-critical region. It falls closer to the mean than alpha is. P is greater than alpha. Okay, so we have decided that any result we will call any result unusual if its probability of occurrence is alpha or less. But this one is this result's probability of occurrence is greater than alpha, not an unusual result. You fail to reject H0. It's just like that. All right, let's call that good.